Good morning children. Today's topic is probability. Already last year we have studied this probability. So just we can revise on that. First is random experiment. Random experiment means an experiment which satisfies two conditions. The conditions are it has more than one possible outcome and we can't predict the outcome in advance. Example, rolling a die, tossing a coin. These are random experiments. Then a possible result of a random experiment, that is known as outcome. The set of all possible outcomes that is known as sample space. Then a subset of a sample space, that is known as event. Then we know what is mutually exclusive event. Two events are said to be mutually exclusive if their intersection is equal to null set. Then mutually exhaustive and complementary events. So now we have to learn the new topic, conditional probability. So what is conditional probability? Let us consider one example. Consider a random experiment of tossing 3 coins. So 3 coins, how to write the sample space? The notation for sample space is S. So sample space means set of all possible outcomes. So we are tossing 3 coins. So sample space H, total there are how many outcomes? 8 outcomes are there. H, then we can write HHT, then HTH, then THH, then HTT, THT, TTH, the last TTT. Just count 6, 7, 8. 8 outcomes are there. Now, E and F are two events. Events means it is a subset of the sample space. Then E defined as at least 2 heads appear. At least 2 heads appear. And F means the first coin shows a tail. Okay, first coin shows tail. So we can write E as set, it's a subset of the sample space. At least 2 heads appear means 2 or more, that's the meaning of at least. So 2 or more heads. So I can write 3 heads, then HHT, HTH, then THH. So there are 4 outcomes. So what is the probability of E? Probability of E means number of favorable outcomes by total number of outcomes. So 4 favorable outcomes, that is in E there are 4 outcomes. So 4 out of the total number of outcomes. Total number means from the experiment. The sample space, in sample space there are 8 outcomes. So 4 out of 8, that is 1/2. Then what is F? F means the first coin is tail. So I can write THH, THT, TTH and TTT. Okay. So P of F is again 4 outcomes by 8, that is 1/2. Then is there intersection? E intersection F, any common element? E intersection F is equal to common element HHT, THH. This one THH. So common element is THH. So what is P of E intersection F? P of E intersection F is 1 out of 8. Now, suppose we are given that the first coin shows tail. Then what is the probability of occurrence of E? So here F happened first. After that we have to find what is the probability of occurrence of E. So E is depending on F. F happened first, then only E. That is known as conditional probability. So if E and F are 2 events, then the probability of occurrence of E if f has occurred. That is denoted as, that is known as conditional probability, and it is denoted like this: P of E given f. You have to use this notation and read as P of E given f. That means f has occurred, then only E. So now in this particular case, if f has occurred, then what is the probability of E means this sample space. Now this sample space reduces to f. From that f only we can find what is the probability of E. Okay. So now S reduces to what? This f. Now the case is the first coin shows tail. From that only we have to find what is the probability of occurrence of E. Occurrence of E means in that how many outcomes are there? At least 2 heads appear. Okay. That way the question reduces. So P of E given f. So you have to check now only this f. No need of S. From this f, in f the first coin is tail. In that 2 heads appear. Is there any outcome like that? 2 head appear, the one outcome is there. So P of E given f, 1 out of 4. Understood this? This is the experiment, that is tossing 3 coins. E and F are 2 even, such that E means 2 heads appear and F means first coin shows tail. Then we wrote everything: P of E, P of F, E intersection F, P of E intersection F. Then if the condition is given as first coin shows tail, then what is the probability of occurrence of E? So that is not the direct probability, it is known as conditional probability, since we have to find the probability of occurrence of E given that F has occurred. F occurred first, then only E happens. So that is denoted like this: E given F. Okay. So now we don't want to check the sample space. The sample space reduces to this set F. Then from that F you have to find the favorable outcome. Favorable outcome means this E. E means at least 2 heads appears. So from this set find how many outcomes satisfy this condition. 2 heads appears. So only 1. So 1 out of 4. We have a direct result, direct formula, that is like this: P of E given F. And this 1 means this 1 is the intersection of E and F. Okay, in E also the same element. So we can write P of E given F as P of E intersection F by P of F. Is it true? P of E intersection F is 1 by 8. P of F is 4 by 8. 8 and 8 cancel, it is 1 by 4 itself. Okay. So the conditional probability. So you have to learn this result. P of E given F, that is the conditional probability of occurrence of the event E if F has occurred, or given that F has occurred. That's equal to P of E intersection F divided by P of F, provided P of F cannot be 0. If it is 0, it is not defined. So this you have to learn. Then the same way we can write F given E. P of F given E. What is P of F given E? P of F intersection E by P of E, provided P of E cannot be 0. And F intersection E and E intersection F both are same. Okay. So this is conditional probability. Now we have properties. 3 properties are there. Properties. The first property, P of S given F and P of F given F, both are 1. Here S is a sample space and F is an event associated to the sample space S. Then the property is P of S given F and P of F given F both are 1. So how to prove this? S given F. By the definition, S given F is same as S intersection F by P of F. And we know that F is a subset of the sample space. F is an event, it is a subset. So, F is a subset of this S means S intersection F is F itself by P of F. So, that is equal to 1. Now, the second property P of, the same property, the second case P of F given F. By definition, we can write it is F intersection F by P of F. And F intersection F, that is same as F itself by P of F. So, it is equal to 1. Okay. Now, the second property related to union. And last year we studied, do you remember, what is P of A union B? P of A union B is equal to P of A plus P of B minus P of A intersection B. So, in the same way, here the property is P of A union B given F. P of A union B given F is equal to P of A given F plus P of B given F minus P of A intersection B given F. This is the property. Provided this P of F cannot be 0. Here A and B are two events associated to a sample space S and FB another event such that the property is like this. So, we can prove P of A union B given F. By the definition of conditional probability, we can write this event numerator intersection the denominator. So, here bracket by P of F. Now, this portion like distributive property, we can write A intersection F union B intersection F by P of F. Now, again that is in the form P of A union B. So, we can write as P of the first event plus P of the second event minus P of A intersection F intersection B intersection F, the whole divided by P of F, or that is same as the first set by P of F plus P of B intersection F by P of F, then minus A intersection F intersection B intersection F means A intersection B intersection F by P of F. Now, this how can we write? A intersection F by P of F. It is same as A given F plus P of B given F minus P of A intersection B given F. So, P of A union B given F. So, you have to learn this. Then P of A union B also. This last year we have studied P of A plus P of B minus P of A intersection B. Using this only we expand here that step. Okay. Now, one more property, that is P of E complement given F. This is the third property. P of E complement given F is equal to 1 minus P of E given F. So, complementary events E and E complement, they are complementary events, complement of a set. So, their intersection is equal to null set. Then E union, its complement is equal to sample space. These are results related to complementary events. So here if E and F are two events associated to a sample spaces, then P of E complement given F is equal to 1 minus P of E given F. The proof is, we know that P of S given F is equal to 1. This is the first property. And S is same as E union E complement. So which implies P of E union E complement given F is equal to 1. So that implies, so using the last property, second property, A union B given F is P of the first event, P of E given F plus P of E complement given F minus P of E intersection E complement given F. Okay. So which implies P of E given F plus P of E complement given F, and what is this one? E intersection E complement is null set. That set is null set, so probability we can say that it is 0. So what is the left side? P of, I didn't write the right hand side, okay children. So I can write P of E given F plus P of E complement given F is equal to 1. Therefore, what is P of E complement given F? It is 1 minus P of E given F. Okay. This is the third property. Now, the last property, P of A union B given F is P of A given F plus P of B given F minus P of A intersection B given F. If A and B are disjoint, then this part will be 0. Okay. So you have to write only P of A given F plus P of B given F. So three properties and a definition. I hope all of you understood this.